So in this video, section 9.7, we're going to be solving nonlinear systems of equations. So the first way is to solve the system of equations y equals 2x minus 3 and x plus y equals 12. First way we know how to do that is to substitution. So we take one of the equations, I'm going to take x plus y equals 12. Take this equation, since it's already solved for y, I'm going to plug it in to where the y was, right here. So x plus 2x minus 3 is equal to 12. Then it's just a matter of, got to add one variable, solve for that one, x equals 5. Then I could plug that 5 value into either equation, back substitute, and solve for the y value. The other way we're accustomed to is elimination. For elimination, what I'm going to do is I'm going to take y equals 2x minus 3. I'm going to put it, change it around a little bit. So I subtracted 2x from both sides. Then I multiplied by negative 1 here. So now I have a system of equations here. And I can add straight up and down, and if I do that, the y's will cancel out. So now I've got 2x plus x equals 3x. Negative y plus y, those cancel out. And I get 3 plus 12 is 15, so x equals 5. From here, same thing, back substitute and solve. The last way, of course, is graphing both equations and find where they intersect. So if I graph y equals 2x minus 3, I would get the following line here. Start negative 3, up 2 over 1, up 2 over 1. X plus y equals 12. If I subtract x from both sides, get y equals negative x plus 12, so negative 1 over 1. X plus 12, so I start 12, down 1 over 1, down 1 over 1. And where they intersect is, of course, the answer. That'd be 5, 7. So x is 5, y is 7. So there's just a short review right there of the different ways that we solve traditional linear systems. In solving a nonlinear system, look at the following example. If we do substitution, 3y minus 10, x plus 38 equals 0. And the other equation is going to be 3y plus x squared minus 4x minus 17 equals 0. So I'm going to, using substitution, I'm going to solve for one of the variables here. I could solve for x or I could solve for y. I'm actually going to solve for y here. So I'm going to get 3y is equal to 10x minus 38. Now I could go all the way and solve for y if I want to, but I look at this and I'm like, hey, there's 3y right down there. So I'm going to take this and put it in here. So 10x minus 38, that's where the y was, plus x squared minus 4x minus 17 equals 0. So now it's just a matter of combining like terms. X squared plus 6x minus 55 equals 0. This one I can actually factor. X plus 11 and x minus 5. So my answer is going to be x equals negative 11 or x equals 5. So here we're actually having two different answers. And then to solve it, I'm going to plug these points back into one of my original equations. So I'm actually going to plug it into this one. So 3 times negative 11. Nope. Plug it in for x. 3y equals 10 times negative 11 minus 38. divided by 3. That's one of my answers. And then the other one, let's plug 5 into that equation. 15 minus 38 is going to give me 12, so y is going to equal 4. So my answers to this problem are going to be 5, 4, and negative 11, negative 148 over 3. So, using substitution, same thing I did for the linear system over here of solving for one variable and then plugging it in. I'm going to do the same thing over here. Solve for one of the variables, plug it in to eliminate it, and then just get it down to the x values. Might be 1, might be 2, maybe none. And then plug it in to get the y values. To solve using elimination, what we're going to do here, just like we did with 2x minus y is equal to 3 and x plus y is equal to 12, we were able to add straight up and down and get values to cancel out. We can do the same thing if we only just have a limited number of variables here. So we're going to do the same thing here. Now nothing cancels out at the moment, so what I'm going to do is I'm going to multiply the bottom equation by 4 to get so I can get the y's will cancel out. So I'm going to get 3x squared plus 4y squared is equal to 48. 8x squared minus 4y squared is equal to negative 4. Now when I add these equations straight up and down, I'm going to get 11x squared, 0y squared is equal to 44. And from here it's a simple process of solving for x. Please note that there's two numbers that work here for x squared. 2 or negative 2. Both of them work. So, since x could be 2 or negative 2, I'm going to have to plug these back into one of my original equations to get what y squared is. I'm going to use this one right here. 2 times 2 squared minus y squared is equal to negative 1. Well, that's going to give me 4, 8. So if I subtract 8 from both sides, that's going to give me negative 9. So y squared equals 9. So y is equal to plus or minus 3. So for the answer 2, when x equals 2, I have two answers. So it's going to be 2 and 3, and also 2 and negative 3. Doing the same thing for negative 2, plugging it in here. Well, that's negative 2 times negative 2 will give me 4, 8. And this is just going to give me the same answer as the other one. Plus or minus 3, so negative 2, 3, and negative 2, negative 3. So I have 4 different answers for this. You may say, how is that possible? How can you have 4 different answers? Well, if we look at this problem right here, this is going to be an ellipse centered at the origin. This problem right here is an ellipse. This, because one of the numbers is negative, is going to be a hyperbola. It's a hyperbola going like this, also centered at the origin. So we can see, oh, those would cross into 4 places. In fact, that's the last way you can check. The third way to find solutions is to graph the equations. and find where they intersect. You can use that using a graphing calculator or Desmos or any other graphing program really. But once you graph it, easy way just to look up there and find where they intersect. That's an easy way to check. On your homework, I'm going to want you to use either elimination or substitution to find your answer graphically. Find your answer algebraically. Then I want you to check by graphing. So use elimination or substitution to solve it, and I want you to check by graphing. Thanks for watching.